With only minutes to go before the start of the race, these drivers make their final preparations. Racing can be hazardous, so for safety, suitable protective clothing is worn. Gloves, goggles and crash helmets are all part of the gear. And so is the special fireproof suit. In the event of an accident, their lives could depend on the clothes they wear. As in motor racing, so in engineering. But is engineering that dangerous? In this workshop, the apprentices all wear special protective clothing. They work in boiler suits and caps, and for certain operations, goggles. But do they wear this clothing for their safety, or simply as means of protecting themselves from the dirt and grease in the workshop? What's wrong, for instance, with wearing just an overall for doing a job like this? It's not only hair that can get caught up in rotating machinery. What about that overall? It may look safe, but is it? This is asking for trouble. And watch that cup. Well, that was a bit of luck, but he's not so lucky here. When you work close to rotating machinery, there are many hazards which, left unguarded, could lead to serious injury. What about those eyes? It only needs one spark to fly in the wrong direction. Plimsolls, or gym shoes if you like. How do you care to be in his shoes if this chuck fell? In the workshop, your safety could depend on the clothes you wear. A cap or hat not only keeps out dust and dirt, it can also prevent long hair from getting caught in rotating machinery. A boiler suit is safe as long as it isn't torn or loose-fitting. Here, rolled-up sleeves are an added safeguard. When it comes to protecting your feet, you need shoes strong enough to stand up to the impact from something as heavy as a falling chuck. This is a test that all reliable safety shoes are designed to pass. Goggles like these are designed to protect your eyes not only from abrasive particles but also from very fast-flying swarf. Now, one way of testing their efficiency is to fire a bullet at them. The goggles are fitted to a dummy head made of steel. The head is carefully aligned just in front of a rifle barrel. And for the safety of the marksman, it's enclosed in a very strong box. For a bullet, we use a small steel ball. The only damage is that tiny dent in the middle. Goggles designed to withstand this test carry a British Standards kite mark with a number 1 to the right of it. Now, besides goggles, there are safety glasses. These are designed to be worn in most workshop situations, but what if there's any of that very fast-flying swarf about? The safest form of eye protection depends on the job you're doing. A welder views through special safety glass that protects his eyes not only from sparks and glare, but also from harmful radiation. When handling hot materials, hands and legs need protection too. Here, asbestos gloves and gaiters are worn. A transparent shield protects the face. Suitable gloves or gauntlets are also necessary when handling material with sharp edges. These are mild steel sheets. They're being pressed into parts for cars. These components are covered in oil. Here, oil-resistant gloves are worn. If oil is allowed to come in contact with the skin too often, it can cause dermatitis. Precautions must also be taken where there's a risk of breathing dangerous dust or fumes. To prevent these painters inhaling the fine particles of paint, face pads are worn. Do you know why this sort of atmosphere is dangerous? In this part of the car production line, each operative wears a plastic helmet connected to a supply of fresh air. This is because they're sanding down lead solder joints. The dust contains lead and, if inhaled or swallowed, could easily cause lead poisoning. A wire rope sling. It's used in the factory and workshop for lifting heavy loads, so it needs to be safe. A sling has a loop at each end which must be strong enough to take the load. Let's watch one being made. A metal ferrule protects the join, and for safety it's squashed onto the rope in this press. Before a sling is put into use, the Factories Act requires it to be tested and certified for its safe working load. In this test, the sling is subjected to a load more than twice that which is considered safe. There are many different ways of using a sling, depending on the nature of the load. The most common method is to wrap the sling round the object, keeping the weight of the load distributed as evenly as possible. When lifting things with sharp edges, it's important to protect the sling with timber or some similar sort of material. Sharp edges can cut into wire rope, and this would reduce the safe working load. But apart from sharp edges, there's another danger. This relates to the angle between the two slings at the end where the hook is. In this demonstration, a sling is attached to each end of the load. At the hook, the angle between them is about 120 degrees. A spring balance records the tension in each sling. Here, the tension's between 40 and 50 newtons. What would you expect the tension in the right-hand sling to be? More? Less? Or the same? It's about the same. Here's the same load, but this time the angle between the two slings is much less. In fact, they're much closer together. Do you think this will make any difference to the tension? It's much less this side, between 20 and 30 newtons. And it's the same in the other sling. So the smaller the angle between them, the less tension there is in each sling. It's always important to keep the angle between the slings as small as possible, within reason that is. Not only that, it's also important to ensure that the load can't slip out. Let's see what happens when the same crane driver lifts a similar load slung differently. Fire. It could mean your job or your life is at stake. If a fire broke out in your workshop or factory, would you know what to do? Have you read your factory's fire drill? These instructions may not be quite the same as yours. Do you know where the fire exits are? Do you know who to tell? In all factories and workshops there are fire extinguishers. Do you know where they are in your place? Prompt use can help to prevent a fire from spreading, but there are usually several different types. Foam, CO2 or carbon dioxide gas, BCF, and of course water. Would you know which to use or even how to use it? Let's start by taking a look at fire itself. All fires need three things: fuel, oxygen, and heat. Now, most fires, like this one, involve solid materials such as wood, paper, and cardboard. For this type of fire, water is usually used to bring it under control. The water has the effect of cooling down the burning material. In terms of the three things the fire needs, water removes the heat. Now, because so many fires involve solid materials such as you find in a rubbish heap, most extinguishers like this one contain water. To find out how to use one, it's essential to read the instructions. Not all water extinguishers are brought into action in the same way. Let's see that particular one put into use. Water should always be used to cool down the burning material near the base of the fire first. Can you think why? Careless burning of rubbish causes thousands of serious fires every year. Now you may think we can use water to cool any type of fire. This is burning petrol. Let's see what happens if you use water here. See how the water causes the blaze to intensify and to spread. For this reason, water should never be used on fires involving flammable liquids such as petrol. Here's one type of extinguisher that can be used: foam. Now let's see how to use it. Foam must be directed onto the surface of the liquid. This is because it's not the liquid that burns, as you might expect, but the vapour above it. Foam has the effect of cutting off the supply of vapour. We can see the principle involved here by looking at our triangle again. Cutting off the supply of vapour amounts to removing the fuel. Not all fires involving flammable liquids can be put out with foam. Here, petrol, leaking from a container, is running down some corrugated iron. If foam were used here, the petrol would carry it away. So, what's the alternative? That was a dry powder extinguisher. But although it's put the fire out, it hasn't cured the leak, so there's still the danger of the fire reigniting. Where electricity is concerned, it's very important to know which type of extinguisher to use. Water or foam wouldn't do. Here's something that would: CO2 or carbon dioxide gas. In terms of those three things the fire needs, we've replaced the oxygen with a gas which doesn't support combustion. So, out goes the fire. There are other extinguishers which work on the same principle, especially effective where motor fires are concerned. This one contains a liquid which vaporizes, but these vapors are poisonous, so should never be used in a confined space. Find out where your extinguishers are and find out which type is which. Above all, find out what you should do if a fire broke out in your workshop or factory, or for that matter, wherever you are.